Today we will be continuing with the seventh chapter, that is the study of gas law. And before this video, we have already discussed about Boyle's law and Charles law, and we discussed them graphically how they variate. The Boyle's law has a negative slope, the Charles law has a positive slope. Now, and also we discussed about how these equations, these relations of Boyle's law and Charles law are used in solving the numericals. Today we will be starting with the next law, that is the gas equation. The gas equation. The gas equation. So this gas equation, we derive it whenever we consider Boyle's law and Charles law in combination. That means we are combining both of these laws to get the gas equation. Okay. So according to Boyle's law, we have. According to Boyle's law, what do we have? We had temperature was constant and the volume was inversely proportional to pressure. Yes or no? Similarly, from Charles law, what do we have? We got volume was directly proportional to temperature. So this is equation number 1, which is for Boyle's law, and this is for Charles law. So if we combine both the equation, what we get is combining Boyle's law and combining these two laws. What we get? Volume is proportional to 1 by V into T. Okay, we have combined both the laws. This temperature was directly proportional to volume. So volume is directly proportional to temperature, and volume is inversely proportional to pressure. Volume is inversely proportional to pressure. Hope this is clear. Now we can write this as V is directly proportional to temperature divided by pressure. So if you remove this proportionality sign, then what we get? We get volume equals to some constant quantity into T by P. So T by P. So if we take P this side and T this side, what do we get? We get PV by T equals to constant. So we got this PV by T equals to constant. Now, this is true for one set of conditions, like initial condition, as we discussed for Boyle's law and Charles law. So if we have two sets of condition, then what will happen? This V1 by T1 will be equal to T. Similarly, if you have final set of condition, like another condition, then in that case we have to take V2 by T2, then again this will be constant. Yes or no? So what we see on the right hand side of both of these equations, we have K constant. That means these two quantities are what? Equal. So if you equate them, what you get? You get this relation which is known as the gas law. What do you get? You get P1 V1 by T1 will be equal to P2 V2 by T2. So this is the relation that is known as the gas equation, and this equation will be used to solve the numericals. It will be applied to solve the numericals. So let's apply it to solve the numerical. So here you can see that how many quantities are there? 1, 2, 3, 4, 5, 6. So out of these 6 quantities, in the question, if you see it properly, 5 of the quantities will be given. you will be asked to calculate the sixth one. So let's apply this gas equation to solve the numerical. And again, for this, refer to page number 127. Page number 127, from where we will be solving numerical based on the gas equation. Now refer to question number 14. So we are going to solve question number 14. So here, what information is given? A sample of carbon dioxide occupies 30 cm³ at 15 degrees centigrade and 740 mm pressure. So here the initial set of conditions is given. So whatever information is given in the question, you have to write them first. So V1 is given as how much? V1 is given as 30 cm³. 30 cm³. P1 is given as 740 mm of mercury, and temperature 1 is given as how much? Temperature 1 is given as 15 degrees centigrade, 15 degrees Celsius. Now this has to be converted into Kelvin. So to convert it into Kelvin, you have to add 273 and you will be getting 288 Kelvin. So the first information you got it from the question. Now let's see what more information is given. A sample of carbon dioxide occupies 30 cm³ at 15 degrees centigrade and 740 mm pressure. Find its volume at STP. So they are asking us to calculate volume. So they are calculate volume. So we need to calculate volume. T2 is given indirectly as they have mentioned at STP. So at STP, what does STP mean? Standard temperature and pressure. Every time it's the same, constant value of temperature and constant value of what? Pressure. So here STP means, what does STP mean? It means temperature is 273 Kelvin or 0 degrees centigrade. Here we are taking Kelvin, so we have to take the Kelvin value. Okay, and the pressure is here in millimeter. So standard pressure is 760 mm of mercury. Okay, so this information, from where did you get it? You got it from STP. So in the question, whenever they mention STP, they ask you to calculate at STP condition. Then every time the temperature is 273 Kelvin and the pressure is 760 mm of mercury. Please remember this. Okay. Now, so out of 6 quantities, we know this 3 was initial condition, and now this temperature is also known, and this pressure is also known. They are asking us to calculate V2. Now we can easily do it. So let's calculate V2. V2 will be equal to P1 into V1 into this T2 will be going that side up, T2 divided by, so you are calculating V2. T1 is already there. T1 into this P2 will be coming in the denominator, T2. So now put the values, whatever information you have written, put the values here. P1 is 740 into V1 is what? 30. Now T2 is given as 273 divided by T1. T1 is 288 Kelvin, and P2 is given the standard pressure, that is 760. Okay, so from this, if you calculate it, if you multiply and divide it and get to the lowest value, then the value that you obtain after calculation is 27.689. So 27.689. This is the exact value you get. And if you want to get in your answer, they have given as what? 27.7. So you can round it off. Okay, so you get 27.7. And since this is, you are calculating volume, and volume is given in centimeter, so this is 27.3 centimeter cube. Okay, this is how we apply the gas equation to solve the numericals. Please practice them properly. You have plenty of numericals in your book. At least, since we have discussed all the two types of laws, the Boyle's law, the Charles law, and the gas equation, all these numericals, you solve it. If you have any doubt, any problem regarding this solving of these numericals, you can always contact me. But your responsibility is now. Your chapter is over. Your responsibility is to solve these numericals. Thank you.